Hi and welcome to the second lesson on Boolean logic. This one is all about truth tables, but before we start I'd like to have a quick go at this starter, see what you remember from last week's lesson. So if A and B are both 0, then what is not A and not B, and what is not A or not B? Well, the answers to this one: not A and not B is not 0 and not 0, because that's what A and B are. Not 0 is 1 and not 0 is 1, so it's 1 and 1. And for an AND operation, if both sides are a 1, then the output is 1. In that case it is. And for the second one, we do the brackets first. So A or not B is 0 or not 0, which is 0 or 1. And an OR only requires one of them to be a 1, which it is. So it's not 1, which is 0. If you're still not sure about that stuff, you need to go back to last week's lesson, have another look at that, because if you're not getting this yet, you're not going to get the stuff we're doing next. Right, so when we do Boolean operations normally, we don't write and, or, and not. We use a different notation. A plus is used to mean or, so A plus B means A or B. A dot is used to mean and, so A dot B is A and B. And a bar above the top of a letter means not, so A bar means not A. So a quick exercise for you to make sure you got the hang of that one. Can you write each of these expressions out in words, like the way we did last week? The first one's done for you. So A bar dot B means not A and B. What's the second one, third one, and fourth one? If you pause the video, have a go at that, and then I'll go through the answers. Okay, well, let's have a look at this. So A plus B with a bar over the top. That bar over the top means a not is applied to the whole expression. So this will be not A or B. Because the A plus B means A or B, then the not applies to all of it. So the not is outside of that bracket. This one here is simply A or B, because A plus B means A or B, and C. And the bottom one, we've got a bit of nested bracketing going on because that bar only applies that A, so that needs to be in a bracket. So we've got not A, but then that not A is ORed with B, and then that is ANDed with B. Okay, so if you got those, well done. The main thing we're doing this lesson, and from this point on we're using that notation, is looking at truth tables. A truth table shows all possible values for an expression. For example, let's look at a truth table for just an OR gate, an OR expression. So A plus B, first of all, we put all possible combinations of the inputs. Now this order here, starting with 1, 1, and then going 1, 0, 0, 1, 0, 0, the exam board we use for GCSE does it in that order. Almost everywhere else starts with 0, 0, then 0, 1, then 1, 0, then 1, 1. I don't know why our exam board does it differently, but this is the order for the exam board. So when you're getting used to truth tables, get used to putting in this order, starting with both 1s, 1, 0, 0, 1, 0, 0. And what we do is, because that's every possible combination of A and B, there are no other values A and B can be, because it can only be 0, 1, and that's every combination. So A or B, we then fill in this for each combination. So when A and B are both 1, A or B is a 1. That's the rule for an OR gate, as long as one of those is a 1. Here, that one's a 1, so it's still a 1. Here, that one's a 1, so it's still a 1. Here, both A and B are 0, so in this case, it's 0. So the value of the output for each input is put in the third column, and that's a complete truth table. I'll just remove the red. Okay, so that's a truth table. That shows us every possible state this expression can be in. So a task for you: can you also do a truth table for an AND operation and a NOT operation? For the AND operation, I've drawn out the table but not filled in the last column. For the OR operation, for the NOT operation, I've not even drawn the table at all. I want you to draw the table, but think carefully about it. With an OR operation and AND operation, there's A and B are both inputs, so we have to have every combination of A and B. With a NOT, there's only one input, A. So this is going to be a smaller table because there's only a single input and there's only two possible combinations of just A. So have a go at that one. I'll go pause the video while you do it, and then I'll go through the answers in a second. Okay, right, so for this one, the rule for an AND operation is that both A and B have to be a 1 for the output to be a 1, and that only happens here. So that would be a 1, but everything else would be 0. So that would be the truth table for an AND. Now for a NOT, there's only one input, which is A, and the output is not A. So the only possible values that A can be are 1 and 0. So the output is 0 and 1, because the rule for a NOT is that it's the opposite of whatever the input is. So that's those. Again, I'll take out my scribblings and put in the formal ones because I'll need you to make a note of these if you didn't quite get them right. Okay, so can you make a note of these? These are the truth tables for an OR operation, an AND operation, and a NOT operation. Pause the video while you do it, and then we'll carry on. Truth tables can also be done for longer expressions, but we generally do that by breaking down those expressions into their component parts. So if we look at this example of not A or B and B, the first thing we'd have to calculate here is not A. So we put that in its own column. That's quite easy to work out. Not A is just simply the opposite of whatever A is. So when A is a 1, not A is a 0. When A is a 0, not A is a 1. The next part would work out, now we've got not A, is not A or B. So we're looking at the column for not A and the column for B, and we're looking for if there's any 1 in there, which there is here, then not A or B is a 1. Here they're both 0, so that's a 0. Here they're both 1, so it's a 1, and here that one's a 1, so it's a 1. And then finally this one here, which is a full expression, we've already calculated not A or B, and we're just ANDing it with B. So here's not A or B, and here's B, and we're looking for where both this column and this column has a 1, and that's when it's going to be a 1. So this one is a 1, this one, that's a 0, so it's not 1 there. Here, both are 1, and here it's 0. So that's the truth table for not A or B and B. Now this truth table actually tells us something really useful. It's not just an exercise for the sake of it. If I highlight these bits here, this final column, which represents the full expression, we'll notice 1, 0, 1, 0, that's identical to B. So this actually tells us that this expression, not A or B and B, actually just equals B. Now if we're doing some circuitry, we can now replace quite a lot of the circuitry with something much simpler. So that's a really useful simplification to do. I'm not going to ask you to do any of these at this stage, but that's the purpose of truth tables. If you do a truth table and you notice the final column follows a pattern of something else, and we know that those two expressions are equivalent. So an exercise for you, can you complete this truth table? This is for a slightly different expression, A or B and not B. Pause it, do that, then I'll go through it. Okay, so the first one we're doing is not B, it's just the opposite of B. So 0, 1, 0, 1. The next one we're doing is going to be A and B, because this part here needs doing before we can AND it with B. So we're just looking at here at A or B. Anywhere that either of them is a 1, it's a 1. So it's that. And then finally we're ANDing this one and this one together. So anywhere where both are a 1, which is just this one here. The rest all have a 0. So that's the truth table for this one. So hopefully you're finding that quite straightforward. Can you now have a go at the quiz on the VLE?